All right, this is a review about complex zeros. It's connected to the fundamental theorem of algebra. Let's make sure you know what that means. So the fundamental theorem of algebra connects this: the degree of a polynomial. And we know that degree means the greatest exponent is equal to the number of zeros a polynomial has. Now, so the degree is equal to the number of zeros. And we know those zeros could be real or complex, or in other words, they could be rational, irrational, or imaginary. So let's practice this. So we have two functions here. My goal is to find the zeros and then to label them rational, irrational, or complex. So I'm going to factor this. So the two numbers here are going to be negative 25 and positive 4. They multiply to negative 100 and they add to negative 21. X squared subtract 25 is a difference of squares. And then x squared plus 4 is not factorable. So I already know that I have zeros at positive 5 and negative 5. If I take x squared plus 4 and make it equal to 0, I can just solve it separately. So I can subtract 4. We know the answer is both positive and negative when solving a quadratic. The square root of a negative number is imaginary, and the square root of 4 is 2. So together that's plus and minus 2i. So those are the, and then if I would label it, these are rational and these are complex, or you could say imaginary zeros. But if you notice that altogether there's 4 of them and that the degree is 4. If I asked you about linear factorization, so if I said write them as linear factors, you would go x plus 5, x minus 5, x plus 2i, x minus 2i. And that's the way to write it as linear factors. All right, practice one more. Write this down, press pause. Can you find the zeros? So I'm going to factor by grouping. I'm going to factor out an x squared. That leaves me with x minus 2. And I'm going to factor out a 16. That leaves me with x minus 2. So one factor is x minus 2, and the other factor is x squared plus 16. So x squared plus 16 is not factorable, so I make it equal to 0. I'm going to solve it. So I'm going to subtract 16. When I square root, the answer is positive and negative. The square root of a negative number is imaginary, and the square root of 16 is 4. So it's positive and negative 4i. So I already know the zeros, so it's positive 2 plus and minus 4i. So that is rational, and these are imaginary, or you could say complex. If I write it as linear factors, we'd have x minus 2, we'd have x minus 4, x plus 4, order doesn't matter, and there you go. All right, Mr. G Math, over and out. Good luck.